Geometry Common Core, the June 2016 Regents exam, starting on number 21. In the diagram of triangle ABC, points D and E are on AB and CB respectively, such that AC is parallel to DE. That's the problem's way of letting us know we have similar triangles. The big triangle and the little triangle here. Because they have a reflexive angle, and then these would be considered corresponding angles of parallel lines. So a lot of similarity taking place. And AD is 24. DB is 12. DE is 4. They want to know what is the length of AC. This is a very commonly set up question, where they basically want to see if you're going to fall for the trap of setting up the wrong proportion. They want to know if you're going to do 12 over 24, that type of thing. That would be false. What we have here is 12 and 4 are two sides of the small triangle. And for the big triangle, we have this whole thing, which is 36, and this unknown side, x. The 24 here is the trap. The 24 does not belong in the proportion here. You may have heard of the term of side splitter, like you can do 12 over 24, but only if I was working with this over this. And some teachers may not even teach that because they want to avoid you making the mistake. So don't, it's always safest to think small triangle, large triangle. So again, similar to a question we did in the last video, I could do like one from each triangle or two from the same triangle, equal to 2 from the other. It doesn't really matter. Like if I do small triangle over large triangle, the 12 corresponds to the 36. Like the top right of the small triangle and the top right of the big triangle. And that is equal to the shortest left side here, 4, and the shortest left side of the big triangle, x. Cross multiply, 12x equals 4 times 36. 4 times 36 is 144, and when we divide by 12, it's going to equal 12, because 12 squared is 144. So the answer there is 12, but I'll write the work down here. 144, divide 12, x equals 12, and x does represent AC here, so AC is 12. Okay, let's look at 22. Triangle RST is graphed on the set of axes below, as shown. How many square units are in the area of triangle RST? All right, there's a couple of ways you could do area. You could try to cut it up into small sections. Like, we know the area for a triangle is 1/2 base times height, but you can only do that if you have perpendicular sides. Are these sides perpendicular? It looks like they are, actually. Right? This is a slope of up 2 over 1, up 2 over 1, a slope of 1/2. Where this is a slope of down 1 over 2, down 1 over 2, negative 1 over 2. So they are perpendicular. So you could figure out the distances of these, distance formula, or, kind of a variation of the Pythagorean theorem, and do 1/2 base times height. And maybe that's the way to go. You could try to box it into right triangles like that you can count. I could count those triangles. I could count, that would actually be kind of tough in this case. Or you could put a box around the whole thing and find the area of the whole thing and then subtract away these triangles. Or you could do something called the shoelace method, which will always work. It doesn't have to be a triangle for the shoelace method to work. Let me show you shoelace method, and then maybe I'll do the 1/2 base times height too, just for practice there too. What we need is these coordinates. So this is -2, 7 for R. Looks like -5, 1, and 1, 2, 3, 4, 5, 6, 7, 7, -5. I just want to take another quick look at that, because if I mess that up, then everything's going to be wrong. So that's 7, 3, 5, 1, 1, 2, 3, 4, 5, 6, 7, down 5. All right. And so the way shoelace works is you can start at any point. Like I could start at point R. And you list them in columns, but then you have to list the points going counterclockwise. So around the figure this way. So the next point is -5, 1. And then the third point is 7, -5. And then you actually have to repeat whatever your first point was again. So repeat -2, 7. And then we multiply down this column diagonally. So -2 times 1 is -2. -5 times -5 is 25. 7 times 7 is 49. And I add the total together this way. And then I'm also going to multiply it the other way. That's why it's called shoelace, because they end up looking like shoelaces. 7 times -5 is -35. 1 times 7 is 7. -5 times -2 is +10. And I'm going to add these together. And so you just need to be careful with the math. I'm just going to get my calculator out instead of switching back and forth and typing this in. Save us a little bit of time here. So let's see, -2 plus 25 plus 49 is a total of 72 on this side. And -35 plus 7 plus 10 is -18 on this side. Now, if you started at a different point and did it and repeated, you might end up with different numbers here, but you should end up, I think, with the same totals. And what we need to do with these is we subtract them, but we do the larger one, or the one on the right, minus the smaller, and we minus 18. And we know that when we minus a negative, it becomes positive, and so this is going to work out to be 90, and we divide that by 2. So the result is 45. So the area, as I see it, is 45. Let me check it one more way. If I wanted to find the length here, I could do the distance formula with these, or I could kind of make my own little right triangle out of this. This would be a 3 by, let me get rid of that little annoying little box, 3 by 6. You know, like 3 squared plus 6 squared, that's 9 plus 36. 9 plus 36 is 45, so it's a square root of 45. So this length here is rad 45. And then down here, let's see, this is a bigger triangle, but the length here is 6, and the length here is from -5 to 7. That's what distance formula really does. It just asks what the length, we subtract these to get the length between them, is 12. 6 squared plus 12 squared, that's 36 plus 144 is going to be 180. So the square root of 180. And if I did 1/2 base times height, now since I know these are perpendicular because they're slopes, it'd be 1/2 rad 45 times rad 180. 1/2, what's rad 45 times 180? 45 times 180 is 225. And the square root of 225 is 15. And it would be half of 15, and this isn't working out, is it? Why didn't that work? 36 and 9 is 45. 36, 144. 1/2 base times height. Oh, I see what I did wrong. I added these. It's not 225. Sorry about that. 45 times 80 times 180. Yeah, 225 is way too small. Is 8100. Yeah, the square root of 8100. And the square root of that, now we're talking, is 90. And half of 90 is 45. All right. So, I mean, shoelace, like I said, is nice, but you got to remember how to do it. Pick any point, list them down in a column, and repeat. And then subtract and divide there. All right, so that took a lot longer on number 22 than I definitely wanted to do. All right, number 23. Graph below shows AB, which is a chord. The coordinates of AB are given here and here. We see that here. The distance from the midpoint to the center, the distance from the midpoint of AB. Now we can figure out the midpoint. We could do the midpoint formula, but I think we could probably just see it. Let's see, is it there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 in each direction. And that point is a 3, negative 2. So the midpoint is 3, negative 2. The distance from the midpoint to the center of a circle is 2. So that means the center of the circle could be here, which is the point 5, negative 2, or it could be here, which is 1, negative 2. All right, so what could be a correct equation of the circle? Well, let's see. It looks like they're all potentially having the center of the circle. So let's say if it's 1, negative 2, that'd be a minus 1 plus 2, minus 1 plus 2. Or if it's the 5, it'd be a minus 5 plus 2, so not that one. So really, what's the radius? So either way, if this is the center or if this is the center, since this is a chord on the circle, that's your radius. You know, you got to kind of picture a circle like that. They're telling you that's a chord on the circle. So a chord goes from endpoint to endpoint. So both of these are endpoints of the circle. So what is that radius length? Again, if you kind of think of it as a right triangle, this is 2 by 5. 2 squared plus 5 squared, that's 4 plus 25 is 29. So the radius is rad 29, but in these formulas, it's radius squared. That's why I need regular 29, not 25. Tricky question, weird how it's kind of set up, but that's 23. 24, and I believe this is the last part 1, so maybe we'll stop here after this question. 24. What is the area of a sector of a circle? So area of a circle is pi r squared, but the sector, what we do is say how much of the circle are we talking? It has a radius of 8, so that's going to be our r squared, and it's formed by a central angle that measures 60 degrees. A central angle is equal to an arc, so we're talking about 60 out of 360 times pi 8 squared. It looks like in terms of pi, so I'm going to leave that alone and just say, all right, what is 60 out of 360 times 8 squared? You can simplify this if you'd like. It comes out to be a sixth of 64 pi, right? 8 squared is 64. So it's really 64 pi divided by 6, and what does this reduce down to? I could divide both of them by 2 to get 32 pi over, right, divide by 2 is 32 pi over 3, right there. That's our answer for the area of that sector. All right, so I think we'll stop here since this is the end of the part 1s, and we'll pick up number 25, the first part 2, in the next video. See ya.